Welcome to Summarize Science. Today we are looking at a breakthrough in audio generation called WavFlow. Most AI systems today rely on something called latent-space compression to handle audio. This essentially means the AI shrinks the audio down into a smaller code before trying to recreate it. While that works, it introduces a middleman that can cause information loss and make the process more complex. The researchers behind WavFlow wanted to challenge this idea and generate audio directly in its raw form. Their goal was to produce high-fidelity sound that is perfectly synced with video or text descriptions. To do this, they used a technique called waveform patchify, which turns long 1D sound waves into 2D grids. This makes it much easier for the AI model to process the data efficiently. They also introduced something called amplitude lifting. Audio waves are often very quiet and close to zero, which makes them hard for AI to learn. By scaling up these signals, they made it much easier for the model to see the patterns it needs to replicate. The architecture uses a transformer model that looks at video, text, and audio tokens all at once. To train such a powerful model from scratch, they needed a massive amount of data. They built an automated pipeline to curate 5 million high-quality triplets of video, text, and audio. This large-scale dataset taught the model fine-grained acoustic patterns that usually require a pre-trained encoder. When they tested WavFlow against existing methods, the results were impressive. It achieved competitive or even superior results on benchmarks for both video-to-audio and text-to-audio tasks. This proves that you don't actually need complex compression steps to get high-quality sound. You can see the difference in these spectrograms, which represent sound visually. For a video of a boxer punching the air, WavFlow correctly identifies that there should be no impact sound. Other models often make mistakes and add strike noises that shouldn't be there. In another example of a horse trotting, WavFlow creates sharp, rhythmic pulses that perfectly match every footfall. This level of synchronization is difficult to achieve when you're working with compressed representations. Let's recap the big takeaways from this study. First, WavFlow shows that generating audio directly from raw waves is not only possible but very effective. Second, they proved that specialized scaling and massive data can overcome the traditional hurdles of raw waveform modeling. Finally, this framework is much simpler than previous designs because it doesn't need a separate audio tokenizer. For the future, this could mean more realistic sound effects in movies and games generated instantly by AI. It opens the door for models that can handle all sorts of sounds, from nature to human speech, with incredible detail. Thank you for watching Summarize Science, and stay tuned for more breakthroughs in the world of technology.